Okay, so today we're talking about 4-5, and this is greatest common factor. I remember when I was a young guy learning this stuff, maybe for the first time. I don't remember if it was first or review, but looking at this saying, okay, yeah, greatest common factor. Interesting. But I didn't really actually know what it meant. Like, what does it mean by greatest common factor? And then as I started teaching, I was like, you know what? I know what it means. It means what it says. So I'm going to keep repeating that concept over and over again so you guys can understand, oh, that's what we mean by GCF. It's not just GCF. It means greatest common factor. Do you know what a factor is? I hope you do by now. It's a number that can divide another number evenly. Do you know what the word greatest means? Usually the biggest or largest of a grouping of something. And then common, that's the one that may get us. But let me ask you this here. Right now, I see common things. I see common shirts on the boys. They have these blue polos that they have in common, right? I can say, and the girls have the same thing, and other boys as well, but I can say that, let's just say the boys with the navy blue Mitchell Road collared shirts. Okay, what you guys are wearing is common to each one of you, right? You don't have the same shoes on, you don't have the same socks, you don't even have the same color hair, but you do have the same shirt. That is common. You share that. Don't you share that? You're like, Mr. I don't share my shirt with them. No way. No. You share it in the sense that you have it in common. If we were to group you by shirts, we would group you guys together. Does that make sense? Okay, because I'm going to use that word common many times. All right, let's go ahead and get started here. GCF, so I'm going to abbreviate it. GCF is the greatest. It's kind of cool, huh? The name says it all. And literally, the name does say it all. The greatest of the factors of two or more numbers. I'll get out of the way in just a moment. Mr. A, isn't that just like saying greatest common factor? Yep, that's exactly what I'm saying. The name says it all. Greatest common factor. Greatest shared factor, you could say. Yeah, let's interpret. I think you guys are bright enough to interpret. Okay, let's look at one method to find the GCF, or the greatest common factor. And this is a method any of us can use, I hope. Let's look at the numbers 78 and 91. Okay, one way to find the GCF of two numbers, I'm trying to find the GCF of 78 and 91, is just to list out all the factors of each. So what are the factors of 78? Well, we automatically should know two of them. 1 and 78 out here. Now, when I list out factors, I tend to spread them out because I know that there are going to be factors in between. I just want to get that. Now, let's do a review of divisibility. Is this number divisible by 2? Yes. So I know 2 is going to be a factor, but 2 times what equals 78?
Some big number.
39. 39 is a factor. And if you didn't know, it's okay, because this method is inferior to the method we will look at. Is this divisible by 3? It sure is. So 3 times what equals 78?
13.
Someone's birthday and they're 30. No.
26. 21. I'm so smart.
26. Okay? Does 4 go into it?
No. Yes.
Yes.
No.
Yes.
Yes. No.
Yes.
All right, hold on. Raise your hand if you're certain, yes or no. You're certain. And then you can give me the reason why. Because like you might be, I'm pretty certain, but I want to be certain.
No.
Okay, Tristan, is it yes or no?
Yes.
Okay. Why?
I don't know.
Okay. I want certainty. Elizabeth?
No.
Why?
Because 7 is not divisible by 4, and in the divisibility rules it says that the last 2 digits of the whole number need to be divisible by 4.
Okay, so that means this right here. These two combined are divisible by 4, and they're not. They're off by a bit. So it's okay. So 4 is not a factor. Is anything else?
6.
Oh, why is 6? Someone give me the reason, please, Josie.
Because 2.
And we know 5 isn't a part of it, but yeah, 6. 6 times what equals 78?
13.
13. Ooh, just barely fit them all. That's all of them. And we're talking about whole number factors, which is nice. Okay, 91. Oh, can I do this again? All right, I know what goes into 91. 1 and
91.
thankfully the gap shouldn't be as big because it's not divisible by as many numbers. Okay, divisible by 2,
No.
by 3,
No.
4,
No.
5,
No.
6,
No.
7.
Yes. Yes. What? Yes.
Yes.
7 has a divisibility rule. It's kind of complicated. I'm not going to spend the time to figure it out, but you just divide it out. Does 7 go into 91? Mm-hmm. 7 goes in that. Watch. 7 goes into 9 one time, right? 7 goes into 9 one time. With the remainder of 2, 7 goes into 21 3 times. So it goes into it 13 times. That's short division. So if you get better at short division, that's what you can do. Any other numbers?
No.
Okay, good.
Can I just put X in the
So I just put. Sorry?
dot.
No, don't put X in the middle. Just leave it like that. You don't have to make it all neat and stuff. It's boom. You got it. Do I have all the factors of 78 and of 91? Good. Yes, sir?
Are we going to have to do, like, is it divisible by like, decimals and stuff?
Oh, no. Yeah, that gets really complicated. But let me look at this here. We've listed out the factors. Do they have any factors in common? In common. Or that they share? Yes, ma'am. Which ones? Okay, they both share 13. Anything else they share? Braden? 1. In fact, here's a little property here. Ready? All numbers that are greater than 0, okay, or greater than, you can even say, of 1. Any two numbers always have a common factor of 1, right? And you're like, I'm thinking of a number right now. 73 and 92. Do they both have 1 in common?
Yes.
Okay, so any two numbers that are whole numbers we're talking about. All right, so we have common 1 and a common 13. Which one is the greatest common factor? Yes, ma'am?
13.
It's 13. That's it. So we say the GCF of, and let me make sure I get my numbers right, 78 and 91 is 13. That is the GCF of 78 and 13, 78 and 91. It's 13. It's the greatest common factor. The biggest factor that fits into both of those numbers evenly. No other numbers can do that for these two. Yes, ma'am.
We have to do
So,
that.
oh, sorry, Elizabeth, then I'll get you.
Are we going to have to write out the sentence?
No. I'm writing that out so you understand what I'm going to say as we keep going through this lesson, because I'm going to say the GCF of these two numbers is that. Wait, he just said 3 numbers. You have to think of the numbers you're talking about, and then the GCF of those two is the last.
So you put 98 and 91 13?
No. That's not what I put. Nor should you put it. Okay, you good on that? Man, I hate this method. I'm just going to tell you right now, I hate it.
Me too.
Because I'm going to look at example number 1, and 315 and 135. You want to list all the numbers that are factors?
Yeah.
No. It's going to take you too long, and you might get one thing wrong, and you're done. And all that work was for nothing. Let's find a better way. So example number 1, and we're talking about 1A. We're going to do the superior method, which is factorization before finding the GCF. Okay, so my two numbers, 315 and 135. Okay, and just to review, can somebody help me out with the factor tree? So just give me what can you break it down? It's tough, isn't it? Some of you are looking at it, it's hard. You know why? Because there's an easier way to do it.
So if it's hard, there's always an easier way to do it.
Not necessarily, no. But in this case, yes. But anyone? Give me the two things you want to break it down to. Yes, ma'am?
63.
63 and what?
5.
So 5 and 63. 300. Yep. 5 and 63. And how'd you figure that out?
Division.
You knew it had to be divisible by 5, right? Because it ends with a 5 or a 0. And then you just divide it out and you get your 63. Hint, hint. You divided. There's another method that does that as well.
No.
Uh-huh. All right. 5 is a prime factor. We're done with that. 63, now you can do it. Tree method's good. 63 gives, what can you get with 63?
9 times 7.
All right, so 7 and 9. 7 is a prime number. 9 is not. We'll break that down. 3 and 3, both of those prime numbers. And I'm going to scoot this up just a bit. Okay, so here are my two numbers. And I got 3 to the second times 5 times 7. Do you see how that's in order? You have your 3, then you have your 5, then you have your 7. Excuse me. Sneezed out. Okay, anyway. You guys good on that? Okay. The superior method, the division by primes, or the cake method. What number is 135? And if you don't know what the smallest number is, I know this number goes automatically into 135. 5. That's a prime number. That's good. 5 goes into 13 twice with the remainder of 3. 5 goes into 35 7 times. All right, what's the next number that goes into 27? That's a prime number. 3. 3 goes into that 9 times. Once you get down to a prime number, you're done. How nice. In fact, you would have done that with this number if you divided by primes. So you're doing that anyway. That's why I like cake method.
Don't you do the multiplication and then add the two sums? Or
Sorry, we haven't gotten there just yet, but you're starting to get it. That's okay. All right, I'm going to list this out as 3 to the third times 5. That's in order. Okay, you got it? You guys okay with that? So I'm getting these blank looks like, are we okay with this right here?
we did that for homework.
So you've already done this, I hope. Yeah, and so it should be reviewed. Now, I'm looking for the GCF, and this is what you have to do. Please listen carefully. Okay, do you guys notice that they both share 3 as a factor?
Yes.
Okay? How many 3s do they share? How many 3s do they share? Be super careful when you answer this. Elizabeth?
2.
2 of them. They share 3 to the second. Don't both of these have at least 3 to the second in them?
Yes.
They have 2 3s as a factor. This one has 2, that one has 3. So they both share at least 2 of them, right? Do they share anything else? Yep. 5. So you know what we do with those 2? Now, anything else that they share, by the way? 1, but that doesn't count. So anything else that they share? Nope. So what's 3 to the second times 5? Well, what's 3 to the second? 9. And 9 times 5 is? That's the GCF. It's 45. Okay, some of you get it, some of you don't. If you don't get it, I need questions. Yes, sir.
Where did the 7 go?
Do they share a 7 as a common factor? So is it part of the greatest common factor? No, because they don't even share it. You're only looking for ones that they share in common. Yes, ma'am.
I'm so confused by how you did the bottom part. I know
Let me help you out if you're confused. Let me do it a different way. Maybe that'll help you out. Ready? I'm going to write this out, not with exponents, but just 3 times 3 times 5 times 7. And then 3 times 3 times 3 times 5. If you could do it this other way, it's better, but this is another way. Don't they both share a 3? Don't they both share 2 3s, in fact? Do they share any other 3s? Nope. Nope. Do they share a 5?
Yes.
Is there anything else they share? So you see how I have 2 3s that are being multiplied? Like both of them have 2 3s in them, right? They share 3 to the second. And they both share 5. So then I multiply those 2 values, and I get my 45 as the GCF. How about this? I'll just keep doing more. I'll do more. That'll help you. Oh my. Let's go with some simple numbers here. Let's go on page 92. Let's look at number 6.
192.
Page 192, number 6. Okay, we're going to go to simple numbers, and maybe to help you to see it. Number 6 wants you to find the GCF of 12 and 8. All right, so what I need you to do is get the prime factorization of both numbers. So here, I'll do the tree for you guys who like that, which is fine. So I get 2 to the second times 3 for the 12. And then for 8, which, man, I've done 8 so many times now. It's almost like we can memorize it. 8 would be 2 to the...
Third times 4.
Sorry?
2 to the third.
Yeah, I heard someone else say it. So it's just 2 to the third. That's it. You guys good on that? Okay. Do you guys see the prime factorization of both? Which factors do they share? Do they share? They have to have in common. Well, let me ask you this. Do they share a 3? No, 3 is not a common factor, so it's not part of the greatest common factor. But what do they share? Michael? Don't they share 2 2s?
Yeah.
This one has 2 of them, this one has 3 of them. So why don't you write 3? Because they share how many? 2. 2 to the second. Right? So they share 2 2s as factors. 2 factors of 2. What's 2 to the second? That's the GCF. Since there's nothing else there, it says 4. Is 4 the greatest common factor of 12 and 8?
Yes.
I thought 6 can go. 6 goes into 12, but does it go into 8?
No.
4.
Yep. Yep.
Yes.
Oh, yeah, it is. Right? That's the only one. That's the biggest one. Biggest one that can go into it. Could 8 go into both of them? 8 can go into that one, but can it go into this one evenly? It's got to be 4. You can see it, and you can see it practically. You can see it mathematically. All right, let's do another one here. Go back to the example, and oh my, they just like big numbers, by the way, on these. Yes, ma'am.
For the cake method, can it only be divided by a prime number?
Yeah, only divide by primes because you want that outside column to be prime numbers, so you just list them out. B on example 1. B is 66, 90, and 150. 3 numbers, that's absurd. Yes, it's just another set of numbers. All right, so what do you think we have to do with these 3 numbers first? Prime factorization of these, okay? And you could do tree method or you could do the cake method. I'll do tree for the easy ones. I'll do cake for the tougher ones. But all these are pretty much straightforward. And don't forget, prime numbers get circled when you're done with them. So I got this right here. Beautiful trees. Almost Christmas time. So I got 2 times 3 times 11. 2 times 3 squared. Oh yeah, it's Thanksgiving first. Almost forgot. All right. As you're going through it, you're hopefully getting this right here. You guys getting this?
Yep. Yes.
I can't read what I wrote.
Oh my. That happens, unfortunately, Bella, and that is not a good thing.
That's because my circles were in.
Okay, are you guys in agreement with these prime factorizations?
Yes.
Darn it.
Okay.
Put that one in order.
Please listen up because I want to help you out. And you'll need this for the future in this lesson. What factors do they share? Give me one factor that they share. Okay, Jensen.
3.
Say that again?
3.
Yeah, don't they all have a 3 as a factor? At least 1 3? So 3 is a shared factor. Anything else that they share or have in common, Marissa? Yeah, they all share 1 2 in there. And I'll put it in order just so you guys can see what I got. Anything else that they share in common? Yes, ma'am?
5.
So this one has a 5. That one has 2 5s. Yeah, nope. What about the 11? They share that in common? Huh. Anything else that they share in common? So you're telling me they only share 1 2 and 1 3 as a factor. So what's the GCF?
6.
The GCF is 6. That's the biggest number that fits into all 3 of those evenly. Biggest number. No other number will do.
Is there any time
Would it be
GCF will
How
lie?
would it be 6?
Well, let's see. Does 3 fit into all those? Yeah. But does 6 fit into all those?
Probably.
It does. 6 fits in that 11 times. 6 fits in that 1. 15 times. 6 fits in that to 25 times. Very nice. Wow, that's quick. So which one of those is bigger, 3 or 6?
6.
So what's the greatest common factor? 6.
But you can do it with 78, 91.
We did. What did we get for 78 and 91?
13.
Is that the biggest number that fits into both of them? Yes. And now we didn't do prime factorization on that. We did it the hard way. We listed all the factors. You want to list all the factors of these numbers?
Well, you didn't.
Oh, it was just picked one. Yes, because it's a different method. Yes. But the first method we did, you have to list them all out. And then you just pick the one that's the biggest. On this method, yeah, you have to multiply, but it's a lot easier than that other method. And trust me, those numbers get tough. Yes, sir. Oh, this guy. Okay, let's look at it. Let me see where we're at. Let's go to example number 3. Example number 3 now deals with special expressions called, what were those things called again? 36x cubed y and 56xy squared. Those are called, they're special names. I'm slipping here. Michael? Monomials. And you're like, Mr. A, I don't think that's true. Look right above in the sentence. The product of the common prime factors of 2 or more monomials is their GCF. Okay, so 36, here we go. 36x cubed y and 56xy squared. Okay, now, Mr. A, you're getting into difficult territory because now you have variables. Okay, what do you think we have to do with these two expressions? Get the prime factors. You remember what you did last night? Do it for these two. You're like, Mr. I don't remember what to do. Get the prime factorization of the numbers and then break down those variables. Okay, that's all you have to do. So here I'll do, again, your tree method. I guess these are like ornaments, right? I got it. It's festive. Okay, so you have your Christmas trees with your festive bells. Red bells. Red Christmas tree.
Red Christmas tree?
Yeah. Okay, so I have the numerical part. It's going to be here, 2 to the second times 3 to the second. Is that correct?
Yes.
Okay, and then I have x times x times x times y. Okay, so that's the first prime factorization. Hope you guys remember that somewhat. Okay, the second one, let me see here, is 2 to the third 7, or times 7. 2 to the third times 7. And then what would the variables be broken down into? Yes, ma'am?
X times y times y.
X times y times y. Do you guys remember this?
Yeah.
You guys okay with that?
Yes.
Okay, so far so good. This is a review. Now.
8 times 4, 36.
8 times.
No.
8 times 4, 36.
Yeah, sorry, I was trying to interpret 8 times. No. Okay, so do we have this here as our prime factorization? Are we good? What factors do they share in common? Which factors? Give me, in order, give me the first one that they share in common according to this listing. First one, yes ma'am?
2.
2, how many do they share in common? 2 of them, right? This one has 2 of them, this one has 3, so in common they share 2. Next?
X.
Okay, wait, they don't share any other numbers?
They share a
They
lot.
are numbers.
Okay, yes. What I mean is these whole numbers. Okay, you're good with the whole numbers. You said x. How many x's do they share in common? 1. Any y's?
Yes.
How many? 1. Anything else they share in common? So you multiply these out, and what do you get?
4xy.
That is the GCF of 36x cubed y and 56xy squared. It's 4xy. It's cool. Sorry, and you can see what I'm talking about. What's cool about this is this little fact here. This may not look like a problem that seems practical in any way, but if you didn't know how to do this, when we get to Algebra 1 and even into later on in this book, If you don't know what the GCF of those two terms are, you're going to have to deal with these the whole time instead of dealing with their easier versions, which I will get to later. So this is super key. I'm already thinking Algebra 1, Algebra 2, Geometry. Please know this. It's going to help you out in all those. Very helpful. Yes, ma'am. Did you have a question? Okay, ready, guys? If you can do these next two, you're done. And you can just start on the homework. But if you can't do it, guess who gets to stay with Mr. A during break?
Me.
Oh, my. No volunteers. No. Just get it done, and then you can start working. I really want you to get these. All right, page 192. Just do numbers 9 and 10. 9 and 10. Yeah, on your notes page, yeah. Page 192, numbers 9 and 10. Well, just look at it. Just don't assume yet. I'm going to write them down, and then I'll break it down into the prime factorization. Negative 5ab, and the other number is 6b squared. Okay, prime factorization here. Remember, if you have a negative, do you remember how to break that down? Negative 1 times, and in this case, 5 times a times b. You have to take that negative out. So that's your prime factorization. Okay, for that first number. The second one, what's the prime factorization of 6?
3 and 2.
Yeah, you put 2 times 3 times b times b. That's the prime factorization of the second number. What do they share in common?
B.
That's it? So you know what the GCF is? It's b. That's all they share in common. That's the greatest common factor. That's it. Now, I'm going to give you this little note. If you can just put your pens down real quick, because I'm going to give you something that's very important. Please look up here, because it's going to help you out. And if you don't know, you're going to be like, I don't get what he's saying. Okay, you notice how these two only share one variable in common? There are times where two or more numbers, so here just two, will share only one factor, and that factor is 1. Right? We call those two numbers, here's the key, relatively prime. Can you guys say that with me? Relatively prime. One more time. Relatively prime. When the greatest common factor of two or more numbers is 1, those are called relatively prime numbers. Okay, you can keep going. You're like, why does that matter? Oh, it matters. Oh, it matters, guys. So you better know it. Tristan, do you have a question?
Yeah.
Go ahead.
If you have any negative number and you want to get the prime factorization of it, you do that every time?
Yep, just take that negative and then treat it as if it were a positive here. Yep.
So like even if you say you have like negative 10, you would just do negative 1 times 10.
You would do negative 1 times 2 times 5. Because you'd break 10 down, right? So yeah, you do negative 1 times 2 times 5. Yep. And basically, you're just trying to get rid of that 1, because maybe they both have, negative 1, and so negative 1 would be a common factor, but in this case, they're not. All right, sorry, number 10. Here it is, guys. 15a squared b squared, 27a cubed b to the third, or b cubed. Okay, who can give me the prime factorization of 15a squared b squared? Jack. Good job. All right, who can give me 27a cubed b cubed? Marissa?
Okay, wait, so what's the prime factorization? It would be 3 cubed times a times b times a times.
Good job. Okay, you guys got that prime factorization? What do they share in common? They share a 3. They share 2 A's. So I'm going to put the 2 A's and 2 B's. They have those in common. So your final GCF would be 3A squared B squared. That's your GCF of those two. How nice. How nice. Kind of, sort of, starting? Yeah. And thankfully, that's why we do the homework. So we get drilling. We drill it into ourselves, and then hopefully that'll help us out more. Okay, let me give you your homework, and I'll help you out if you need it. It is 13 to 35 odd. 13 to 35 odd. I know. 45 to 47.
Actually, you might have a little error.
And Swivl, have a great day.